All right, today we're going to dive into the absolute heart of Node.js, the event loop. Seriously, this is the core mechanism that makes Node so incredibly fast and efficient, letting a single thread juggle thousands of connections. So let's break down how it all works.
This really is the million-dollar question, isn't it? I mean, if you've ever worked with Node, you've probably scratched your head wondering how a famously single-threaded language can possibly handle the massive workload of a modern server. It feels like it shouldn't be possible.
And the answer, in 3 simple words, is the event loop. This is the secret sauce. It's the engine behind Node's entire asynchronous, non-blocking superpower. And in this explainer, we're going to pull back the curtain and see exactly how it pulls off this incredible feat.
But to really get why the event loop is such a game changer, we first have to understand the problem it was built to solve. Because in a single-threaded world, the biggest enemy, the one thing you can't afford to do is wait.
See, by default, JavaScript is synchronous. Just think of it like a single-lane road. Every line of code is a car, and it has to go through before the next car can even start moving. So what happens if one car just stops, say to read a big file or call out to a slow API? Yep, the entire highway grinds to a halt. Total gridlock.
And this slide just lays it all out, plain and simple. On the left, you've got that blocking model. A big database query comes in, and boom, the whole app freezes. The user is just staring at a spinning wheel. But on the right, in the non-blocking world of Node, we do something different. We tell Node, hey, go work on this query and just tap me on the shoulder when you're done. And our main thread, it's totally free to keep serving other users, keeping everything snappy and responsive.
And look, this isn't just some academic exercise. This quote hits the nail on the head. When you're running a server, blocking the event loop is a disaster. It means new requests from users are just piling up, waiting. Your server gets sluggish, things start timing out, and your ability to handle traffic just tanks.
Okay, so how does Node actually pull off this non-blocking magic trick? Well, it's not just one thing. It's really a team of different components all working in perfect harmony. So let's meet the key players in this process.
This journey right here is everything. Okay, so first, your regular code runs on what's called the call stack. When it hits an async operation, like reading a file, Node doesn't wait. It hands that job off to its powerful low-level APIs, which can actually use other threads behind the scenes. And your call stack, it just keeps on chugging along, totally unblocked. Now, once that background task finishes, its callback function gets put into something called the callback queue. And here's the crucial part. The event loop is like a bouncer. It's constantly looking at the call stack, asking, are you empty? Are you done yet? Only when the call stack is totally clear does the event loop say, okay, next, and grabs the first thing from the queue to run it.
All right, so we've got the big picture. But if you really want to master this stuff, we gotta go deeper. Because the event loop isn't just one simple spinning circle. It's actually a cycle made up of very specific phases, and each phase has its own unique job. So here's the tour of the main phases. The whole loop kicks off with the timers phase, which is where your setTimeout and setInterval callbacks get handled. Then it moves on, and a really important one is the pull phase. This is the workhorse where most of your I/O callbacks, like from file reads or network requests, get processed. Right after that, it hits the check phase, which is specifically for setImmediate callbacks. Then it wraps up with close callbacks. And once it's done, if there's still work to do, the whole cycle just starts right back at the beginning.
And this is why knowing those phases is so dang important. Just look at setTimeout with a 0-second delay versus setImmediate. You might think they do the same thing, but they absolutely do not. Because they live in different phases, timers versus check, their timing is different. Let's say you're inside an I/O callback. setImmediate is guaranteed to run right after in that very same loop. But setTimeout, even with a 0 delay, has to wait for the next loop to come all the way back around to the timers phase. It's a subtle but powerful difference.
Okay, but just when you think you've got a handle on it, modern JavaScript comes along and adds another twist: promises. And it turns out, promises get special treatment. Their callbacks, they don't have to wait in the same line as everyone else. They get to go in the fast lane.
This is a huge concept to wrap your head around. We actually have 2 different queues. The main one, sometimes called the Macrotask queue, is for our regular stuff, timers, I/O, setImmediate. But then there's the Microtask queue. This is the VIP line. It's reserved for promise callbacks, your .then and .catch blocks. And this VIP line has a much higher priority. It gets to cut in line.
And this number, just the number 1, tells the whole story. After just one single task from the main queue is finished, the event loop stops what it's doing. Before it even thinks about grabbing the next main task, it looks at the Microtask queue.
and it runs everything inside that VIP queue until it is completely empty. That's what I mean by VIP access.
All right, I know that was a ton of theory, so let's talk about what this actually means for you, for the code you write every day. Let's put this theory into practice.
And this, right here, is the big warning sign. Because even with all this amazing async machinery, the callback function itself still runs on that single main thread. So if your callback has some big, heavy, synchronous calculation in it, you're right back to square one. You're blocking the loop and killing your server's performance.
So think of this slide as your new set of rules for writing awesome non-blocking code. The main idea is just never make that main thread wait. That means no long calculations, no synchronous file reads, no synchronous crypto operations on your server. Always use the async versions for I/O. And if you have a genuinely CPU-heavy task, offload it to a worker thread. Keep that main loop free and clear to handle incoming requests.
Look, if you walk away with just one thing today, let it be this. The event loop is incredibly powerful, but it's counting on you to do your part. Your job as a developer is to keep your callbacks short, sweet, and fast. Get in, do the work, and get out. Let the event loop get on to the next task. That is the real secret to a high-performance Node.js app.
So there you have it. You've seen the whole journey, from the call stack to the queues to the phases and even the VIP microtask line. The question now is, what are you going to do with this knowledge? How will you look at your own code and make it play nice with the event loop? Thanks for tuning in.